This was me teaching RLCs to Zach earlier. That was actually kind of fun. We need to continue this at some point, Zach. But let's see. What do we got for questions today? All right, first one from Dylan X Flair. Oh, interesting. We got some interesting usernames on today's queue. What do we got for me? Oh, I like this. We got some linear algebra to start things off. Might be a little scary. There we go. Show that the divergence and curl are linear operators, i.e. that the divergence of CU plus DV is equal to C div U plus D div V, and that also curl can work the same way, where U and V are vector fields and C and D are probably scalar constants, I'd imagine, right? Yeah. Okay. Cool. Thank you, Guitar Freak.
Good job.
Appreciate you. What the hell is this? This isn't that bad. This is technically vector calculus, I guess, technically, or Calc 3. Yeah, I'll call it like Calc 3. It's like, make sure my chat's working and everything. There you go. There's that one. And then connect Discord, TikTok. TikTok's being weird at allowing my group chat thing to work, but I'll figure it out. Not bad. Dude, Calc 3 is not that bad. Calc 3 is nice. Yeah. What's the upside down triangle? Oh, good question, Star Prod. Okay, so yeah, this thing's called nabla. Nabla is a word for like, it's kind of like a fancy derivative. It's a derivative that happens in a lot of different directions at once, I guess. Right? When you take calculus, you learn about, oh, if I have some function, let's say y is equal to like 5x cubed plus 2x, then you could write the derivative as just like dy dx is equal to like blah. What's a derivative? A derivative just figures out the rate of change, just how much a function is changing. But this is doing it in one direction. So, for instance, this graph would probably look something, I don't know, like this. This shows how much the slope is changing in regards to x, reference to x. So you see how this function's like changing in a bunch of different places, right? You can think of the slope of it being different. That's what a derivative is. And more importantly, this is the derivative in just the x direction, with reference to x. We're seeing how much the y value is changing when the x value changes. So to me, this is like one direction of things, not like the band. But vector calc, or Calc 3, starts putting everything topsy-turvy, and it's like, okay, let's look at things instead of just like y versus x, let's add like z as well. So 3D graph of, let me think, divergence, gradient, curl. I just want like some pictures of it. Excellent, there we go. Cool. Yeah, this looks cool. So this is like an example of a 3D graph showing, instead of just like y versus x, this is called a vector field because you can think of it as describing, how the water is moving on a surface. And things like curl, which is this fancy thing here, nabla with a curl. Is that a black hole? It looks like a sinkhole. But yeah, this is called curl. This measures how much your vector field, or whatever, your field of whatever, is spiraling around something. Whereas you can have then this is called gradient. So in this example of just a regular derivative, we were seeing where the slope in reference to the x direction, like which way it's moving, up and down. Gradient then looks at it across like the entire like 3D plane. Frame mogging, to be exact. Yes, I guess it is frame mogging. What's up, Black Bill? Yes, I did see that. The ASU frat leader, he has a ridiculous set of shoulders, dude. That dude needs to get off the fucking TRT, man. That's nuts. But this is an example. Yeah, this is cool. This is like gradient. So the nabla thing looks at the slope of this whatever field in a lot of different directions, not just one. Hope you make it up there, brother. I hope the best for you. It's a great thing you're doing for people. Aw, thank you, dude. Appreciate you. Anyways. Okay. Sorry, that's just like a brief, like, 1-minute explanation of what all these different things are. Curl is how much something curls. Gradient is where, like, the maximum value on something is. It points towards that. And then I think divergence, yes, divergence measures whether something has, we call it, like, sources or sinks. So whether, like, arrows are, like, coming out of an area or whether arrows are flowing into an area. Curl is, like, if they're flowing around an area. Someone else has a better, like, simple explanation for high school kids, let me know. But I feel like that's kind of cool. All right. Is it like magnetic fields? Yeah, it's exactly like magnetic fields. Magnetic fields use a lot of these identities. If you ever end up taking, like, Physics 3 and stuff, these are kind of become the default stuff. Can you open my submission? Is it safe for work, Black Pill? You got it, because I'm opening this live on a stream, so it better be safe. If it's not safe, I'm gonna get you.
Disqualified.
I hope you'll still be here for the next 2 years. I hope so too. Yeah, I hope so. I mean, I'll try, but there are things outside of my control. It's safe for work. Trust me. Said no one ever. Oh, this guy. Yeah. Okay. Yes. No. I'll pull it up for you, Blackpill, in a second. Let me stay a little bit on topic here. Is that the electricity thumb thing? Yes, it is also the electricity thumb thing. But these equations you will use in physics, AP Physics C specifically, and really the E and M part of it. And these are the exact things. Look, nabla, right, with a dot product, which is called divergence, and then nabla with a cross product, which is called curl. The Jacobian, yeah, the Jacobian also shows up. That doesn't really use nabla, though, does it? I feel like the Jacobian isn't it? It's, I'm trying to remember what it is. It's like JR cross J theta or something, and then you do this. And then this is how you do, I think, coordinate transforms for integrals. Well, Stokes' law and Green's theorem will actually end up using a lot of this as well. You appreciate the calming music? Yeah, it's all AI generated. Don't tell Zach. But yes, that stuff comes up as well in Calc 3. So back to this question of the original one. Okay, cool. DMs. I'll ping you when it's your turn for your question. So go practice some piano. Let's see. Show that the divergence and the curl are linear operators. I'm curious what it means by, like, show. What am I allowed to use? Because there are a lot of, like, fun vector identities, I guess. But do I have to prove the identities, or am I allowed to assume they're true? Right, these are all of them. I know, it's a lot. There's a lot of these identities. Because, yeah. Oh, interesting. Wow, this is a fun one too. Wait, what's going on here? Divergence of U. What's up, Amir? Divergence of UA is the same as U divergence A plus A divergence U. This doesn't include matrices. No, matrices don't really deal with this. This is fascinating. I guess I could do it with cross products too. Do I really want to do that? This is Calc 3, Brayden. Yeah, that's what this is. Let me pull it up real quick. No, Jeff. Jeff's always like, he's gonna give up on this. I'm just curious how much they want us to prove. What are you seeing, bro? You're seeing Calc 3 is what this is, yeah. What's up, 1K?
Good job.
Okay, I think I kind of see what I want to do. Yeah, let's fuck this. We don't need this stuff. I'm just gonna assume. No disinfonts. Yes, exactly. We just have to bash it out manually. Exactly. Right. Okay. So let's talk about like what divergence is. Right. Okay. So let's assume that you have some vector. Some vector W. Okay. Which would then have components, let's say, W1, comma, W2, W3, right? Right? And then let's come up with some other vectors. Let's say, for instance, that vector U has components U1, U2, U3. And that vector V has components V1, V2, V3. And then let's assume that vector W is equal to vector U plus vector V. Yeah, you have to do it in R3, right? Yeah, exactly, right. No star pro, that's not how it works. Okay. Yes, so vectors are kind of like points, except they always kind of measure the path from the origin to that point. So if you ever see a vector that looks like this, like 1, 2, 3, this means go 1 in the x direction, go 2 in the y direction, go 3 in the z direction from the origin, and then connecting from the origin to that point. That is your vector. That's your arrow in direction. So these are just fixed vectors. Yeah, for sure. So we can just write out what let's look at linear. Let's focus on divergence, right? So divergence, so div.w, right? We know this is, so nabla is an operator that looks like this. So d dx, and then it's plus d dy, and then it's like ddz, right? Or actually, sorry, no. But it has components. It's like this. This, I think, is how you kind of like describe nabla, right? So if we want to say div.w, let's remember how dot products work, okay? If you have something that has, like, let's say an x, a y, and a z component here, dotting with something else here that has like an x and a y and a z component here, the dot product is this times this, plus this times this, plus this times this. So in this case, we have ddx, comma, ddy, comma, ddz, and that's dotting with w1, comma, w2, comma, w3, right? Which would mean that each of these just like act on the respective component. So this would be equal to dw1 dx plus dw2 dy plus dw3 dz, right? Okay. And now let's then assume that if w is equal to u plus v, right? Then we can say that w is the same as u1 plus v1 here, comma, u2 plus v2 here, and then u3 plus v3 here. And then I think, yeah, Eric's right. But they depend on X, Y, and Z. Yeah. Yeah. Dun, dun, dun. Okay. And then, let me see. They wanted, even more so, sorry, they wanted scalars on these things. CU and DV. Okay. So let's say this. Okay, let me do this. Let's say W is equal to CU. Yes, sorry, they're vector fields. Yeah, exactly. Yeah. You're right. It's not a single vector. I got you. Okay. So this is CU, DV1, CU2, DV2, CU3, DV3. What's up, Rex? Good morning.
Good job.
Okay. So then, any comments on AOPS Intermediate Algebra textbook? What does AOPS stand for? This right here is W1. This is W2. This is W3. So div.w, which is the same thing here now as div.cu plus dv. Here, let's keep this. We're just gonna like put it back together. This is Calc 3. This is Calc 3 is what this is. Okay. Is equal to ddx of this plus ddy of this yes, calculus and vectors. Yep. Yeah, these are arrows. Plus ddz of this one. Okay, and then like Eric said, we're just going to show that partial derivatives, yeah, have linearity basically to it. Really silly. Boom, boom. Okay, so now you learn this in pretty early calculus. If you take the derivative, for instance, ddx of like a plus b, this is the same thing as like dA dx plus dB dx. You can always distribute the derivative. Oh, IMO. Oh, I don't know. I don't know much about IMO. Wow. So this is the same as, let's say, C, and then this is a constant, and whenever you have constants with derivatives, you can always pull the constants out in front. So this is going to be C du1 dx plus d w equals 2u by pronunciation. W, oh wow. That's a good one, I like that. Partial v1 dx plus, oh man, this is so annoying, but okay, fine. Yeah, it's just it's a lot of annoying writing stuff out. Okay, plus d dv2 dy plus c du3 dz plus d dv3 dz. Okay, and what are we trying to prove? We're trying to prove that that is equal to, oh, c div u plus d. Yeah, okay. All right, cool. All right, so this is the divergence of cu plus dv, where c and d are constants, or scalars, sorry. U and v were vectors, or vector fields. And so now what I can do is I can group all of these together. And notice that this is c times du1 dx plus du2 dy plus du3 dz. And then I can group all these together. This one, this one, this one. And show that this is equal to d and here, let's just copy this. And then this is dv1, dv2, dv3. But lo and behold, this right here is also the same definition as div.u. And this is the same thing by definition of div.v, or divergence of v, sorry. So, now we've effectively shown that this thing is equal to this thing. And I think that's literally just what they wanted to show. Yeah. C div u plus d for d div v is equal to the div of cu plus dv. I don't know. Looks pretty good to me. I think I'm gonna call it. This is good. I didn't give up on it, Jeff. It's kind of, I mean, it's kind of a silly proof, honestly. Yeah. All you had to do was... Oh, thanks for the jewels, Blooder. Partial derivative chain rule problems when you have 5 sub-equations or whatever are hellish. I can't remember why I wrote something half the time. Yeah, I mean, you're not really learning anything at that point, dude. Dude, 5 levels of chain rule is just... That's just sadistic. Kyoto... What's up, Hecker? For questions, you gotta go do it there. Grade 12 Calc and Vec Fun. I just migrated in North America, and I'm starting to love math because of awesome teachers. And this evening chill channel, I'm at Advanced Functions. Nice. Yeah. We were doing some vectors and stuff on. I mean, this is kind of vector calculus, is what it is. And it's basically doing the same stuff you do in Calc 1 and Calc 2, which is integrals and derivatives, but you just do it in more than one dimension. So instead of just doing things in X and Y, you do it in like X, Y, and Z. Or then sometimes they parameterize it, and it's like X, Y, Z, and T. That's really all it is. Okay. Nice. This was Dylan X Flare. Okay. I'm not going to prove the curl one just because this already took a lot of time to do. But if you want to do the curl one, I think it's the same technique, Dylan. Just define U and define V as like U1, U2, U3, V is V1, V2, V3, and then show that when you do cross products, which these you end up doing, I call it like the T method. But for instance, it's just a bunch of determinants. So this is like I, J, K, and then it's like ddx, ddy, ddz, and then this would be like u1, u2, u3. And then you can just show that this is going to spit out a bunch of stuff. This is going to spit out a bunch of stuff. And if you were to do it with this as well, you could... there's linearity into just the scalar multiples. and the partial derivatives. Z is a fancy way they say Z. I just don't like saying Z because then it's like, is it Z, is it C, or is it Z, D? Like, they all sound the same. Z, nothing sounds like Z. Yeah. But that's where that comes from. Okay, so I'm gonna go post that screenshot in. Wow, we got a lot of questions today. This is actually kind of awesome. Wow. But that'll go in our Discord. So let me see where I put it. Admin console. Mark that as done. Done. Yep. Okay. So then, Dylan, here is your submission, and then the nice cool thing here is there's your screenshot with your solution, and then also it'll timestamp the live stream and what time that we did this, so you can always go back and watch it later. Really cool. So another benefit to joining our Discord. Anything we do here, any question gets recorded, both in like how we did it on the stream, also the screenshot of like the solution. So yeah, B, C, D, and E all rhyme and there's standard answer choices. Yeah, but I guess A is different. All right, let's go check out next question. Live queue. This is what you wanted to send me, Black Pill? Clavicular getting mogged by this ASU frat guy? Oh, this is not natural though. Don't do this, please. I love working out. I'm a big fan of like working out and doing weights. Don't do that. Don't. That's not healthy. Brutal. Yeah, he did. Yeah, but I don't know, man. That's gonna lead to like health issues later. If you're that triangular. Bro, since when are you into looks maxing? That's just someone who submitted it. I'm not a looks maxer by any mean of the word. Yeah. I think it's cool if you want to work on your health and you want to work on like your fitness, and I think those are all very cool things. I don't think we should ever like shame that. You know, if you want to become a faster runner, you want to become a stronger lifter, those are all great things. And you'd be very surprised to notice how if you have discipline in those fields, they'll help you out in other fields. You know, if you can have the discipline to go to the gym and like do things, you'll probably do your homework more as well. Like, it all resonates. So I agree that you should do those things. Just don't do it for the sake of vanity or like, I don't know, this looks maxing thing where people like hitting their chins with, I don't know, rocks and stuff to cause swelling so that your chin looks more defined. That's just dumb. It's just fucking dumb. What? No, go lift. Go lift some weights.
Who are you telling to lift weights?
Dude, everyone should lift weights. Well, I mean, unless you're younger than like 14 or something, let your body develop first. But everyone should lift weights. I think weightlifting is a great thing in life. Dr. Goals is a physics mogger.
Everyone try calisthenics.
Calisthenics is great too. Everyone should do cardio. Everyone should eat healthy. Everyone should put down the nicotine vapes. There's a long list of things you should do, and like I don't do all those things because nobody's perfect. But anyways, let me do this one. Black Pill says, would you rather have a long and boring life or a short and very interesting life? Pin to win? What? Oh man. I say why not both? You can have a long life that's interesting, Black Pill, if you're smart. Okay, for what values, if any, of the constants A and B is a vector field irrotational? What does irrotational mean? Also, Shaq, mute yourself. Do I keep hearing your clicking? I'm hearing the clicky clicks.
Oh, my bad.
Yeah.
I was waiting for you to like look at
What's
your
up?
Twitch chat.
My Twitch chat? There's... Oh, me first. Oh, nice. Okay. Yeah, you can go next. Where's your question, though?
All right, let me know when is that.
Did you submit it?
I put it in the office hours chat.
No, you got to put it in the queue. You got to go
Put it in
the
the
queue.
office hours chat.
Put it in the queue.
I don't know how to submit that.
We'll go figure it out. You're a smart boy.
I'm old as hell, bro.
You're very smart.
I'm old as hell.
Okay, go figure it out.
I'm old as hell.
All right.
I'm just like you.
Okay. Oh, curl of V is equal to 0. Okay.
I'll be back.
All right. Check. All right. So, irrotational. Yeah, that's cool. I didn't know about that. Calc 3. Yeah, this is mainly college. But you could take it in high school if you're in like a very advanced high school. Or if they offer like community like dual credit classes, that would work. Okay. All right, check. I just woke up to bullshit on my phone. Just read the most incel sentence in my life. What incel sentence did you read, Fortnite? You and Blackpill need to get a room together. I know you guys love each other.
My man.
Bro can't back scratch. Yeah. Yes, I agree, Abdu. Yes, I agree. All right. So let's find the curl of this. Oh, this is cool. So we're literally gonna do what I was talking about here, right? We're gonna do this, but we're gonna do it for this question. This is cool how people's questions all relate to each other. Math is all connected.
Good job.
Okay. Curl of U. I, J, K. And then this is going to be ddx, ddy, ddzz, or z. And then this is going to be u1, u2, u3. And then what we're going to do is we're going to find the determinant of this. Okay? Now, how you do determinant? For a 3x3, I like to use the T method. So what I'm going to do is I'm going to create, kind of looks like a T. I mean, it'll eventually look like a T when it's this way, but just trust me for now. And then now we just take a determinant of this 2x2, which is going to be this. Okay. So this one would end up being du3 dy minus du2 dz. Okay. So you go this one minus that one. That's the first part. Okay. Then you move this thing over. And then, okay, also, all of this is now in the I hat direction. Then we move the T over, and we do this. So this is going to be du3 dx minus du1 dz. But then this is in the negative J hat direction. There's an it's like a parity thing or something, but it goes like plus minus plus. So then this is gonna be minus this whole thing in the J hat direction. Not that we really care though, right? If I want the curl to be 0, I don't care about plus or minus. I just need everything here to be 0. Okay, so then this one is plus. Let's do it this way, right? That's gonna be du2 dx minus du1 dy, and then that's going to be in the k hat direction. Cool?
My man.
All right, let's go do it. What do we got? All right, and then from this, u1 is equal to y cosine x plus axz. u2 is equal to b sine x plus z. And then u3 is equal to x squared plus y. Wow. All right, so now we just get to have a lot of fun doing all these partials. Okay, so partial means that we take the derivative with respect to just this variable, and anything else is considered a constant. So du3 dy means I look at this, I take the derivative of it, but I only consider things that are y's. Okay? And so, oh, what's up, JC? Sorry, I didn't see your Twitch chat thing. Sorry. There was so much going on in the chat. JC says, I went back to the gym after 6 months of not going, worked out for like 2 years prior, and all my strength evaporated. Oh no.
You done messed up, Aaron.
And it does come back way faster. It does. Yes. Good. Welcome. Well, thank you for going back to the gym, JC. Thank yourself. But yes, great. Yeah. Doesn't matter how long you've been out. Go back and things will get better in life. It's like learning a language too. A lot of I technically speak Italian, Spanish, and English, but the amount I can speak them right now is very low. Italian especially, because I have no one to speak Italian to. Spanish I'm decent with because my neighbor doesn't speak English, so I have to speak Spanish to her. So if you have something to practice with, it comes back a lot easier. Yes, yeah, the soreness, Jade Gamer, yeah, they call it DOMS, delayed onset muscle syndrome. What is it? What is DOMS? It's always the second day. The day after is okay. It's the second day after working out that really sucks.
Surprise, motherfucker.
Anyways, okay. So for this one, du3dy, this is just going to be 1. Because this with respect to y is 0, this with respect to y is 1. And then du2dz, that's also going to be 1. So we have 1 minus 1. Oh, beautiful. This shit's already 0. Love. Okay, fine. All right, this one, du3dx, that's going to be 2x, and then minus du1dz, so that's, okay, this with respect to z, this is the only thing that has z in it, and so everything else is a constant, and so the derivative of z is just 1, but then times the constant, so this is 2x minus 8ax. Okay, cool. And we know this has to equal 0. Okay. And then this one, du2dx, well, the only thing that has x is this, and the derivative of sine of x is cosine of x, but then b is like a multiplier on it. So this is just going to be b cosine of x minus du1 dy. Okay. And so this is the only thing with y. The derivative of y is just 1, but then this is like a constant attached to it. So this is just going to be minus cosine of x. You missed a curl question. Oh, yeah.
Oh, yeah.
We had this one. This was also curl. I didn't have time to do this one, Zach. I stopped just doing... I just showed that, like, the divergence was linear. But, a linear operator. But, yeah, now we're doing... This is another cool little... We learned that irrotational, Zach, irrotational means that the curl is equal to 0. I feel like it was kind of a made-up word. Anyways, okay, so this also equals 0. So, for what values, if any, of a and b is the vector field irrotational? So, that's when 2x minus ax is equal to 0. Or, I mean, I guess, so, they just want values of a and b, though, right? Okay, so, 2x equals ax. I'm going to cancel the x's. I know that's sometimes a bad thing to do, but I'm just going to do it. I'm sorry. Okay. So a equals 2 is one of them, right? And then from this one, you have b cosine x minus cosine x. Incompressible. Yes, I've heard that one. Div f is equal to 0. Yep. So fluids are incompressible, right? Usually. Okay, so this is b cosine x equals cosine x. I think we can just, like, divide that, right? And so I can just say, like, b is equal to 1. B is equal to 1, right? So I think that's okay. Yeah? Yeah. Okay, cool. A equals 2. B equals 1. Bingo bango. Cool. That was Cunny Kel with all the K's in it. Okay. Cunny Kel. That's a fun username. But I hope that helped you. Yes, Shaq, you did redeem the me first thing. Yeah. Now crappy chemistry. Don't say that too loud. JC will get upset. No. Chemistry's great. Okay. Let's see. So yes, so if you want to ask a question, the best way to do it, again, is on our website, actualofficehours.com. Submit a screenshot, and here's the queue. There's a lot of questions so far, which are great. Wait, why did Cunny's not go away? Should have gone away. Oh. Oh, sorry, I gotta delete it. There you go. Okay, now it's updated. Okay. But we do have a thing that rewards people that watch the Discord. Watch the Twitch stream for a while. You can always buy channel rewards, and one of the channel rewards you can buy is called Me First. So if you've been watching for a bit and you've built up points, you can buy that perk, and I will skip the queue and answer yours next. So Shaq did jump the queue. This is cool. This counts as a question, Shaq. Maybe you want. What do you want to know about this though, Shaq? Because I mean, it is a function. It is cool, but what do you want me to do with it? You want to solve it? Okay. Well, solving means it would need to be equal to something, but we can simplify it. That's cool. We can simplify it. Yeah. Okay. We can simplify. Okay. All right. X squared minus 4x plus 3 over x squared minus 9. So here we go, Shaq. I'm gonna make you at least learn something, right? Do you know how we can simplify this thing right here? Maybe you want to come in the Discord so it's not so laggy. Factors, yeah, basics, my jam. We love this stuff. Yeah. It's nicer than what we've been dealing with like previously. This other stuff's been like kind of tricky. Factors, no. You don't know how to? Okay, well, I'm gonna teach you how. All right. In this case, so we're gonna try to factor both the top and the bottom. The bottom is easy, but I mean they're both not terribly difficult. In this case, you just look for what two numbers multiply to positive 3, but add up to negative 4. Okay. So I need a number here times a number here that equals 3, but then I need it also to add up to negative 4. Kind of one of the easy ways to do this is just to write out the factors. 3 only has one factor. It just has 1 and 3. Not very complicated. But I need it to add up to negative 4. So in that case, I need this to be negative 1 and negative 3. Right? 3 and 1 is also, yes, technically, but it's symmetric, right? Yeah. So negative 1 times negative 3 gets you positive 3, and then negative 1 plus negative 3 gets you negative 4. So that tells you right away you can write this as x minus 1, x minus 3. Because the 4 has a negative, exactly. Okay. This is called a difference of squares. Where anytime you have a squared minus b squared, this can also be written as a plus b, a minus b. Okay? So you always want to try to see like, oh, what does this look like squared? You know? Oh, well, it's just x squared. So cool. Right? So this looks the same as a is equal to x, because then you have a squared, right? X squared. And then b in this case is equal to 3. Right? Because this looks the same as x squared minus 3 squared. And when that happens, right? When I have something squared minus something squared, I can write it as 2 factors. That plus this, and then that minus this. Hecker, is this your question? No, I don't think so. This is Shaq's question. So this becomes x plus 3, x minus 3. Okay? So now... So yeah, x does have... Yeah, so answers is interesting. It has 2 different roots. So, Shaq, when we think about answers, if you were to set this, for instance, equal to 0, there would be 2 distinct values of x that would cause that to happen. Yeah. When you set it equal to 0, those are quote-unquote what we call the answers. When you're factoring, you're just turning something that is in x squared, so technically quadratic, into something that is only in terms of x to the 1. And then it can have a bunch of these. You're so out of the math game? Well, it's okay. Welcome back. It comes back. Just like JC going to the gym.
Oh, yeah.
Comes back. Okay. Right. Okay. So this is another way to write this. The reason why, the reason why this is useful, putting it in factored form, is exactly what Jade Gamer is saying. If I want to graph this, it's a lot easier to do it once it's in factored form. Because from this, you can figure out where there are horizontal asymptotes, for instance, and vertical asymptotes, and all sorts of stuff. But here, let's start with the zeros. Zeros are cool. So zeros is where the numerator equals 0, but not the denominator. Yeah. Because if you get 0 on the top and 0 on the bottom, then no, it's technically undefined. You can't have 0 over 0. So looking at this, you should notice that you could simplify this because these two things technically cancel. Right? You see I have an x minus 3 factor on the top and x minus 3 factor on the bottom. If the top and the bottom are getting multiplied by the same thing, you can technically cancel them out. Because this is like, oh, times x minus 3 divided by x minus 3. The thing that's tricky here, though, is this is technically called a hole. This is technically a hole at x is equal to 3. So if you make your graph, you have to put like a circle there, because technically this function as it stands is not defined at x equals 3. Okay. So once that's out of the way, the zeros is where the numerator is equal to 0. And for this to be equal to 0, you just need x to be equal to 1, right? So x equals 1, y equals 0. This is a 0 per se. It's a coordinate, exactly. Yes, this is a coordinate. Yeah. Yeah. So this is 1, 0. And that's the only 0 you have. The hole existing at 3 actually is real. And if you were to plug in 3, for instance, you would get 2 over 6, I guess, right? Right? 3 minus 1 would be 2. 3 plus 3 is 6. 2 over 6 is 1/3. So this would be 3, 1/3. This is not a point, though. This is not a point on the graph. It's going to be like a hole for it. Okay. So then the last kind of like thing to draw this, it's, removable discontinuity. Right, exactly. So you could graph the 0. So 1, 0 is definitely something, right? Vertical asymptotes occur where the denominator is equal to 0. Yes, we could include the domain. Yes, let's include the domain as well. You're totally right, Amokayato. So the denominator is equal to 0 when x equals -3, right? So the graph doesn't start at 3. So watch. That's just one of the places. So here, when x equals -3, the denominator is 0. No. X equals 1, y equals 0 is a point. But then also, x equals -3 is what we call a vertical asymptote. So here, this is like 1, 2, 3. Yeah. You're being hyperbolic. Not wrong. Okay. And then I think the next thing you could do is figure out where the horizontal asymptote is. Which, determining horizontal asymptotes, you don't even have to look at this. You can look at your main thing here, and you're just going to compare what's the biggest power on the top to the biggest power on the bottom. Since the biggest power here is x squared, and the biggest power on the bottom is also x squared, this means your horizontal asymptote is located at whatever the coefficient is in front of the one on the top divided by the coefficient of the one on the bottom, and of like the lead. They call it like the leading power, I think, technically. Yeah. So this means I have a horizontal asymptote at y equals 1/1. And this is just y equals 1. So if you wanted to draw a horizontal asymptote, that ends up looking like this. Right? Cool. And then from that, you can basically draw your graph. Jade says, honestly, never knew that. I'm at university. Guess you can still learn stuff from simple questions. Yeah. I mean, that's the whole point of this stream also, is that no matter how old you are, how young you are, or whatever the fuck, like, you can always learn something from these. And I learn things from questions too. So there you go. And this is probably what the graph would look like. And then, yeah, there's a hole technically at 3, a third. So at 2, 3, there's technically a hole here. We should draw like a hollow circle. I might as well quit while I'm here. Yes, you can also think about it in terms of a limit. Dojo is exactly correct. So yeah, there's a couple different ways to think of horizontal asymptotes. There's the quick hack, which is you just compare the powers, right? And do different things. If the power on the bottom is bigger than the power on the top, it's y equals 0. If they're the same, it's the ratio of the coefficients. If this is 1 greater than this one, you technically don't have a horizontal asymptote, but you do have an oblique asymptote or a slant asymptote. And you have to do polynomial long division to figure out what that is. And then if this is 2 bigger than this, then there is no horizontal asymptote. But where it comes from, Dojo is exactly correct, is you divide the top and the bottom by the highest, like I say, effective power of x, and then you take the limit as x approaches infinity or negative infinity. So, for instance, in this one, x squared minus 4x plus 3 over x squared minus 9. The highest power of x is x squared. So you just do everything over x squared. And right, that would give you 1 minus 4 over x plus 3 over x squared over 1 minus 9 over x squared. And then horizontal asymptotes are really asking, like, what happens to my function as I go all the way to the right, so when x goes to positive infinity, or I go all the way to the left, which is x is equal to negative infinity. And that's the same thing as taking a limit, right? So you're just taking the limit as x approaches, like, plus or negative infinity. And looking at this, right, anytime you divide by infinity, that thing is 0. As long as it's not infinity divided by infinity, right? Yeah. So this goes away, this goes away, this goes away, and you're literally left with 1 over 1, which is the same thing. Yeah. So that's where it all comes from. I have actually a really cool video on this one. Where did I put it? It's on TikTok for sure. Poggers. Yeah, it's... Thank you. I do need to hydrate. What's up, Sam? I haven't seen you in forever, dude. What's up? Good to see you, Sam. How's life? But here you go. How to graph polynomials in factored form. You should go watch this video if you ever want, like, the big guide on, like, how it works. Oh, this isn't rational functions. Sorry. This is still cool, though. It's also graphing stuff, and it deals with roots and things. Is infinity over infinity equal to infinity or 1? So, technically infinity over infinity is undefined. Yeah, you technically can't do it. We get kind of, we get around that, because yes, Rook, if you were to just plug in infinity as it stood, like into here, you'd get like infinity squared minus infinity, and then this would be infinity squared. You can't really deal with this. Because infinity is like, well, how quickly are you going to infinity? This is why infinity minus infinity does not equal 0. And by the same token, like infinity over infinity, you don't know which infinity is bigger. Infinity is not a number. Infinity is like a concept. It's like, think of like, it's the biggest number ever, but I don't know how big it is. But I just know it's big. The way we get around that is... Yes, well, okay, so yeah, the limit as x approaches infinity of 5x over x is technically, yes, sure, it's 5 times infinity over infinity. The difference is we do like some algebraic tricks where we say like, well, I don't care what x is. I know that x divided by x is always 1, right? So this just goes away. And then that's why you're left with 5. This is also how like L'Hopital's rule works. Yeah, L'Hospital. The L'Hospital method, yeah. So L'Hopital's does the same thing because you take the derivative of 5x, you get 5. You take the derivative of x, you get 1. It's the same thing. But yeah, if otherwise you can't just cancel it. So for instance, if you were to say e to the x over x and the limit as x approaches infinity, technically this is infinity over infinity. You can't say this is 1. No. Also because e to the x and x are not the same thing. Once you end up using L'Hopital's rule though, this ends up becoming e to the x over 1, which is just infinity, and so now you can see that the limit is infinity. And that also kind of goes back into math. You start learning about what are called like the hierarchy of like size, I guess. So for instance, a to the x will always beat out x to the a, which will always beat out I don't know, like x, which will always beat out. There's like I think logarithms in here somewhere. I forget. It's like big O notation too as well, right? So if the top infinity grows faster than its infinity, if the bottom infinity grows faster than its 0, yes. I mean, in simple terms, correct. But if you want to be rigorous about it, you have to show it using L'Hopital's rule, which is showing that the derivatives eventually become something finite. Yes, yeah, true. Indeterminate, yeah. Yeah, sorry, did I say undefined? Well, undefined, does it not mean the same thing? You can't determine it or it's not defined. How about it's like, yeah, this is called indeterminate form because you haven't determined yet what it is. But you can determine what it is if you end up doing L'Hopital's rule. Anyways, okay, cool. Good question, Zach. Shaq. I really like doing the slant asymptotes are really fun. I'm a big fan of the slant asymptotes. It's also cool to see how those work, the slant asymptotes, because also with limits, it's just a remainder that like goes to 0. Yeah, it's super cool. Okay. Undefined is more general. I think square root of negative numbers is undefined in the real numbers. Yeah. Oh, okay, but undefined is not indeterminate. All right, let's see. I was going through a lot of stuff. Where are the questions? All right, next one is Gladiator. Dude, what? Wait, what the fuck is this?
Surprise, motherfucker.
What is this? What do you want me to do with this Gladiator? Why? Why is this happening? Dude, no. Why? Why are we graphing? Why are we naming this? You did something, but I think it's wrong. Okay. You have to name it. Okay. Mm-hmm. Where's JC? JC, where you at? Where you at, JC? There he is. Name it Bob. Diheptanoic acid. Yeah, you got a bunch of hydroxides on things. What are the oic acids? I think the first thing... Okay, so this is an amino acid, no? Right? I need the structures of them. I think it's an amino acid. Or, wait, they call these functional groups, right? Yeah, wait. No. Oh, this is so low res. Okay. Carboxylic acid. My dog says that's rough. Rough. Yeah, okay, never mind. The amino acids have nitrogen in it. This just has fluorine. Right, okay. Okay. You can do biochem? Sometimes I can. Okay, this is... Okay, here we go. This is what I want to look at. Okay. Okay, so the carboxylic acid part is the COOH, which is on the right. Okay, I agree with that. Which is what you have here, I guess, right? Double bonded OOH. But then you have another... What's with all these OHs? This is definitely... Right, this is a carbon. So this makes it a carboxylic acid. Propanoic, they're calling this propyl because, yeah, you have 3 carbons, right? Ethanoic. Yeah, the hydroxides are just groups. Yeah, I think these are just groups. And so is the fluorine. The double bond, though, is weird. Because that, to me, makes me think it's like heptenoic. Right? Anytime you have ene... Is the longest chain 10? Okay, well, let's see first. 1, 2, 3, 4, 5, 6, 7, 8. So no. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I agree there's 10. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And okay, for the naming convention, I think you refer to this thing as the first carbon. I think this is the first one. Right. So wait, what's 10 carbons? Deca? Is it deca? Like decane? But then there's a double bond here. Okay. So I think it's decanoic acid. But then what I think I want to do is I want to say dec and then 1, 2, 3. I want to say dec 3 ene. The cis and trans, yeah, we don't need to worry about that yet. Because I think you need to refer to this double bond as well as being the dec 3 ene. What's up, Bedlam? And then, right. And then, I think it's going to be 2, 3 dihydroxy 4 fluoro. When I was in college, we did acid. We did name acid. Okay. 4 fluoro dec 3 enoic acid. I think that's what this is. Oh, wait. But then there's also a fucking... This group. Sorry. Sorry. We gotta do more. Oh. TikTok's mad at me. One sec. TikTok's mad. TikTok says, "Are you real? Are you real today?" I am. Okay, and then this is... Oh, man. Wait, is this also something here, or is this erased? Alice Cooper says it's cold Ethel. 1, 2, 3. So then I think it's 5 propyl. I think it's a propyl though, no, right? I see 1, 2, 3. Or are you saying this is also there? Dude, what is this, dude? Who designed this chemical? Okay. I think that's it. Let me see. Let me see. Like, carboxylic acid with a double bond. What's up, Isabella?
Good job.
Yeah, it's like nomenclature. I don't think your teacher will give you that, because that's like not even real. I don't think that thing exists. I don't think carboxylic acids have like double bonds in other places. I'm not seeing any examples of it, you know. Isabel says they don't. Thank you, Isabel. Okay, so I think this is just like some freak of nature that got created, right? Send it to ChatGPT. I don't think Chat would do this. You think mine is correct except for the alphabetical order? I thought you do number order first. Is it not number order and then alphabetical? I'm glad I didn't do chemistry beyond age 16. I couldn't even remember which was the atomic number, which was the mass. Oh no, dude. Oh man. Well, I mean, the mass is always twice the atomic number usually. The bigger one. Let's see. Let me ask Chat. It's IU Pack is who it is. Hecker, is your question next? No, it's quite far down on the queue, Hecker. Do you have the me first thing you can buy on Twitch? If you can do that, you can move it to the top. Otherwise, yeah, you have to like kind of ask once the stream starts. Otherwise, the queue gets like pretty long. Okay, alphabetical order of substituents. Yes. Okay, you're right. You're right. When is office hours starting? So we don't have office hours tomorrow. If anyone ever wants to figure out like when we stream, here's the calendar. Next stream is Thursday at 5. Yeah. Okay. Yeah. I think you're right, Gladiator, alphabetical, but also I don't think your teacher's gonna do that to you. But yes, alphabetical. All right, cool. See you, Hacker. All right. Let's see. Yeah, you're welcome, dude. Don't worry. I don't think your teacher's gonna be that mean to you, dude. That's like really, really ugly. Now back to math. Yeah, what do we got for math? Let's see. Last semester, the class average was a 50? Oh, dear. Ooh, here we go. This is fun. Rook says, am I a math or physics or engineering grad student? I was many, many years ago. I got my PhD in physics in 2021. Now I just do this as part of a nonprofit to help kids out on live streams. Social media stuff. Where's DM Scrader? What's up, DM? We're going to do yours. You're next. I kind of like this. This is kind of fun. Hey, it's my turn. Yeah, nice. Thanks for waiting. Okay. A couple has $5,000 to invest. Wow, who has $5,000 in this economy?
Huh?
What? Who's just got $5,000 laying around? Talk to me, bro. What? Okay, first of all, this is ridiculous, dude. What? Who has investment options at 18%?
Good job.
This is like some Nancy Pelosi insider trading, dude. What? 16%? Dude, what? This is not realistic. Listen to the youngster calling 2021 many years ago. You know what always like bugs kids out when I say I was born before Google?
You done messed up, AA Ron.
I was around before Google was around. Stock market's on margins. Yeah, maybe. Yeah, yeah, Google was invented in like the year 2000. I was born in 1990. I was 10 years old when Google came out. Back then, Google was just a search engine. Gmail was an exclusive thing. You had to get an invite to get a Gmail. Jeff was born before the internet was public. Yeah. Yes. Yeah. Same dojo. Yeah. I got an invite. You remember getting the Gmail invites? They were coveted. Soon you're gonna be an edit where they ask you what year you were born and then edit a dinosaur. DARPANET? Yeah, that was a thing. I don't think I was around for it. I mean, I was around for not Telnet. What was it called? It was like before the internet, but it was like really, really, really sketch. ARPANET. Yeah, there we go. Okay. All right. If they plan no deposits, no withdrawals for 5 years, which options will give them the largest balance? Use a mathematical model. Great. Yeah, so the compounding is different here. Yeah, so this is compound interest. We need another equation for this. Here, I'll just pull it up. Yeah, this is cool. Nice. I like this. I love when people make nice diagrams that I don't have to like redraw. Yeah. They changed it from ARPA to DARPANET. Yeah. The DARPA challenge is still like a really cool thing. That's how they come up with like the self-driving cars and stuff. You put in the model? Yeah, so this model you have here, you forgot the compounding, which is the only part you missed here, right? You have to do R and then divided by M, where M is the number of times per year. So on the first one, yeah, it is 5,000. I'll agree with that. But then it's 1 plus 16%, so that's 0.16 divided by, if it's compounded monthly, right, you're good here, divide by 12. And then to the 5 times 12, or 12 times 5, sure. Right? Yeah, the books use, I agree, Amo, they really do. Back in my day, the internet came on CDs. Yeah, dude. America Online, which I think only recently just shut down. Yeah, September 30th, 2025 was the last dial-up service. 34 years. The AOL CDs were hilarious. Yeah. Who remembers these, dude? This was how you got 500 hours free on the internet. This is what you had to do to get the internet. Yeah. Okay. Divide there and multiply there. If that's a good way for you to remember it, sure. Okay, so 18% semi-annually, right? So that's 0.18 over 2 to the 2 times 5. And then quarterly, right, is 4. And then this is going to be 1 plus 0.17 over 4 to the 4 times 5. Okay. So all it has to do is just do some math. I wonder if... Do you think anyone could just eyeball this and figure this out? Would be kind of cool. That's my calculator. Use the binomial theorem. Okay. We'll show that. Yeah. So here, Blue, we're gonna do something like a little fun, a little advanced, just to kind of like show with people how this works, to try to guess what it would be. You don't need to know this, Blue. Yeah. Yes. You are just gonna use a calculator and figure out the highest version, but to give you like a little cheat sheet or like I say like spoiler alert, like into the future. Here's another cool thing that we learn. 1 plus x to the n is approximately the same thing as 1 plus n times x. Right? No, it's 12 times 5, not 12.5. Because it's 12 times per year times 5. 2 times... Netscape was the best, dude. Yeah, I use Netscape. Yeah, okay. Yeah, this is called the binomial theorem. And... yeah, it has to kind of do with, like, Pascal's triangles, I guess. This is it. Where is it? Where? I just had it. No, where'd you go? Where'd you go? Yes. I mean, this is it, but I need it looking nicer. What? I had it. It was somewhere. Man, where was it? 1 plus x to the n. That's all I want. All I want is that. There we go. I like this cute little... Why can't I open images? What is going on here? What the hell? Excuse me? There we go. I don't know why I was doing that. There we go. Okay, so, yeah. Wait, is it 1 minus nx? No, it should be 1 plus nx. This is what I want. K-Pack says, I want to find someone that would like to... Oh, thank you, Amakayato. Appreciate the donation. See you on Thursday. Thanks for coming by. Big thanks for the donation. Canadian dollars. Anyone seen that movie? I think it's called like Civil War or something. And the person tries to buy a sandwich or buy gasoline and they won't take US dollars. But then they say like $100 Canadian. And they're like, ooh.
Oh, yeah.
Yes, we will take the Canadian dollars. Yeah, it's similar too. So Isabella's already calculated all the balances, which it looks like option B is going to be the best. But this is another cool way to write it. So 1 plus x to the n is the same thing as 1 plus nx plus n times n minus 1 over 2 factorial x squared. Yada, 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 yada. It keeps going like forever and forever and forever. It's an infinite series. So if you want to just be something that's like, yeah, it looks like a lot of bleh. I know. But a strategy that you'll use a lot, especially in physics, is you only look at the first couple terms. So for instance, you only look at these terms as being something that really matters. And you think everything else is just like whatever. We don't really care about it. Yeah. That's one way to do it. Because eventually, so x squared, x to the third, these things get really, really small. It stops at n terms. What do you mean it stops at? Oh, okay. Okay, K-Pax, I'll take a look at it. Yeah. So, yeah. One way to do this with what we had here. So what was this? Eventually, all those terms become 0. Exactly. I agree. Let's say, for instance, for this one, let's try to estimate it. This would have been 1 plus 0.09 to the 10, right? Which from our formula here, right? 1 plus x to the n is the same thing as 1 plus n times x. So that'd be 1 plus 10 times 0.09. Okay. You only lose 6 months.
You done messed up, Aaron!
Yes. Yeah, you can use a calculator. And Isabella's already done it. I appreciate it, Isabella, for you doing it. Thank you. So what? This would have gotten you 1.9. And that's just this part, right? So that times 5,000 is around like 9,000, I guess, right? I think it's actually yeah, it's 9,500. 1.09. Oh, Jeff, you lose another year, dude.
Surprise, motherfucker.
Jeff.
Oh, no.
Okay, wait, sorry. But yeah, okay, let's just use the calculator. I think Isabella already did it first, actually. I should just go check her work, but okay. I'll do the middle one because we think this one's the best. So 1 plus 0.09. This is why it's an approximation. It's not the best. To the 10. That's 11,836. Yeah. You could live forever. Yeah, but it wouldn't be any fun. This is what what's his face Black Pill Ascension was saying. Would you rather live a long and boring life or a short and interesting one where you're wrong a lot of times? B gives the largest balance after 5 years, even though it compounds only twice a year. The higher nominal rate produces more growth than the monthly compounding at 16. I like that. That's a great explanation, Isabella. So yeah, and then here, so let me pull up Isabella's work, so that we don't have to. Where's my chat? Chat. No, I can't see my chat. I mean, approximation is essentially 5 times the interest rate. Yeah. There's also that doubling thing. This is from Isabella, by the way. So Isabella says that choice B is the most, and I agree with that because that's what we got here, 11837. The rule of 72. Yeah, that's it. Remind me the rule of 72? 72 divided by the interest rate is the amount of years it takes for something to double. Yeah. Okay, cool. So for instance, if you had something at a 36% interest rate, right? 72 over 36 would mean 2 years for it to double. Okay, so the correct answer here is B. And then, yeah, so actually pretty cool here. In terms of... in terms of what this was, 72 divided by 18. Let's just see what it was. That's around 4, right? 4 years? 4 years to double? And it certainly doubled after 5. So it probably doubled after 4. So I agree. Yeah, 72 divided by the rate. This is it's a cool, like, we call this a back of the envelope or, you know, back of the hand type of approximation. This is a cool thing to know. Yeah. I know we're supposed to use, like, APR, which is effective, but whatever. Semi-annually is basically the same as annually. So, yeah, 72 divided by the percent rate equals the number of years to double your investment. What's up, JC? Did you go to the gym? This late at night? I was calling upon you earlier because one of our students apparently was given this thing to name, which... I don't know, just like absolutely horrendous. I was like, cool, it's a carboxylic acid, but can carboxylic acids also have double bonds here? I don't think it's like real. What's up, Penn Center? We can't call it the rule of 69.
Nice.
Yeah, Blue said this is why I asked here because I get to learn extra helpful shit. Yeah, fuck yeah, dude. Okay, nice, Jade Gamer. It's almost 4 a.m. Yes, have a great stream. You too. Okay, so here... Oh, 69... 69 is not closer. Oh, 69 is 1 closer to the answer for the doubling time, not 72. So wait, so here's my question here. JC. Is this trustful for my test mark? Yes, Blue. JC, if I have... Let's just say I have this, which this would be what, 1, 2, 3, 4. This would be butanoic acid, right? Sorry, let me show you. Yeah, sorry, my bad. I was yeah. This would be butanoic acid. Because 1, 2, 3, 4, yeah. You get what I'm trying to draw? Yeah, okay. But if you had a double bond here, per se, would that be bute, like, 2-ene anoic acid? Or bute 1-enoic acid? Oh. Or 2. Okay, cool. Alright, that's all I was wondering. Okay, cool. Blue says, thank you, Penn, for the extra info. Yes. You can call it the rule of 69.
Nice.
All right, cool. Good question there, Blue. Do you have any Calc 2 vids? I definitely do. Yeah. What do you want to learn in Calc 2? Thank you, Isabella, by the way, for helping for this one.
Yeah.
The rule of 69. Well, imagine if we called it the rule of 67.
Surprise, motherfucker.
Oh, no, dude. Don't call it the rule of 67. Where to send screenshots? actualofficehours.com. Right there. Send it. Nice. Good question, DMs. I don't know what to learn, really. I have an exam tomorrow and I'm cramming. But she's basically area under a curved disc and shell method. Cool. I've made videos on those, by the way. I've definitely done the what is it? The disc method, the washer method. I hate the shell method.
Disqualified.
But yeah. What was the 67 joke gladiator that they made? So yeah, if you're looking for videos, Mannix, here I do Volumes of Revolution. This is a pretty good one, pretty good video. And then this is another one where it's like harder. But I need to make. There's a part 3 and a part 4 I want to make for even harder stuff. It's on my list this week to do. Time to start a new brain rot. Yep. All right. Let's see. Next question on the queue. I want to try to get through everyone's. Had a lot of questions today. It was really cool. I appreciate everyone submitting stuff. Let's see what we got. DeSantis. Ooh. This is some linear algebra. Is this linear algebra or vector calculus? What is this? Zero curl, yet the field is not conservative.
Surprise, motherfucker.
Oh, let me give you a coin DM. Sorry, forgot. There you go. Okay. This is no high school level. Yeah, this is college for sure, Abbas. Oh, you made the answer 67?
Good job.
That'll happen. What the hell's going on here? Just to waste time, could someone figure out the power series for log of 2 over log of 1 plus r? Yeah, see, at least 6-7 is now cringe, so it'll stop. Okay. Show that the curl of that is 0. But that the contour integral of f dot dr is not 0. If the contour is a circle in the xy plane, theorem 7 does not apply here because the domain is not simply connected. The field f is not defined along the z-axis. Right, because if x and y are equal to 0 here, yeah. Yeah. This, like, screws up. 4 is 70.1. Wait, what? What is 4? This is the integral around a pole. Yeah. Right, yeah, because when x and y are equal to 0, these are issues, right? I mean, I could show the curl of this is 0 pretty quickly, right? We already did that. We did curl stuff. Where was that? Here? Let's see. Isabella says, if curl f equals 0 in a simply connected domain, then f is conservative, i.e. f is equal to yes, is the gradient of some potential. I agree, there's a potential function, right? For some scalar potential. Yes. But the argument they're saying it's not simply connected because at the origin, the field breaks. .7888 is a random guess. Okay, because look at this real quick. All right, so in this case, right, this here is like U1. This is U2. This is U3. So du3 dy is 0. du2 dz is 0. Great. du3 dx is 0. d1 dz is 0. du2... Okay, this one's actually interesting, though.
Nice.
Thanks for the follow, Yu. Okay, so ddx of x over x squared plus y squared minus ddy of negative y over x squared plus y squared. Is that equal to 0? 1 over stuff equals minus 1 over stuff. Yeah. I mean, I guess I can do the quotient rule, right? Because these will have the same denominators. So this is 1 x squared plus y squared minus 2x times x, right? That's the derivative of this times that. And that's all over x squared plus y squared squared. And then that's minus this one. Derivative of the first is -1. X squared plus y squared minus the derivative of the second, which is 2y times -y. She curl on my Taurus till I diverge. God damn it. JC, dude. Damn. That's a good one, dude. I didn't know about that one. I'm going to have to use that. Bishlama says, I used to watch your streams in the background while I goon, and now I can't goon without hearing your voice, lol. Appreciate it, dude. Whatever it takes for you to learn math, you know, whatever these days. Ends justify the means, bro. All right, this is x squared plus y squared. And then this is minus 2x squared. And then this is minus, so it's plus. So that's plus x squared plus y squared. And then this is plus, no, minus is minus. Minus 2y squared. Doesn't everyone goon to math?
Surprise, motherfucker.
Apparently JC does when he's talking about curling my Taurus till I diverge. Curl on my Taurus till I diverge. Curl on my Taurus, kids these days. Or polynomial. Oh, Chris. Oh, Chris. You can't be that explicit on my chat though. Yeah. Be more creative. You gotta be a little bit more creative. A little bit more creative. I'll allow it if it's creative. So wait, I'm curious here though. I don't get that the curl is 0. I get that it's supposed to go away. Did we fuck up somewhere? You're good, just subtract. I feel like when I subtracted, I didn't get the right thing, though. Pen, you know? I feel like I didn't get the right thing. Because, this is negative and negative. No, Chris, you can't do that, Chris. That's not creative. Oh, Jesus. Okay. All right. Thank you, Pen. Y'all behave in my chat, please. Otherwise, yeah. Otherwise, I allow Pen to ban you. What did I fuck up here? Gold, you have 2 x squareds and 2 y squareds. Oh my god. Yeah, thank you, dude. Yeah, Pen's like, here, I'm fighting off the gooners, and Dr. Gold can't add fucking basic algebra here, dude. Thank you, Pen. Yes, okay, this is 0. This is 0. Nice. Gold's too busy winding around his pole. Okay, great. Okay, yes, it is 0. Okay, wait. Bella, what are you saying to me about, like, about some stuff here, though? You were saying some stuff. Let me find it. Wait, where'd it go? Oh, you retracted it. Oh, never mind. Okay, cool. All right, we proved that the curl is 0. Curl is 0. Yet it's not conservative. I feel like that requires a little bit more Annular ring into house. Yeah, I feel like this requires a little bit more. Okay, here we go. Let me convert this into Markdown, just so I can see it. Bella, one sec. Let me convert to Markdown. Who did I vote for? I voted for Andrew Yang. Because Trump is a liar, and I didn't like the DNC ramming Kamala down my throat. Wasn't a fan of that. You voted for Trump? You can't vote. You're a Canadian citizen, Penn.
No.
You can't vote. You can't vote in the U.S. elections. So you basically voted for Trump. I don't think that's right. I think that's actually a really I don't like that at all. And that's a serious problem with the two-party system.
Nice.
Is that if you don't vote for someone, you're voting for the other. I think that's just fucking wrong.
No.
Like, no. A wasted vote goes to yeah, if you're a cuck, sure. Yeah, but that's not how it works. Wasted votes don't go to the winner. That's not no. No. That's wrong. JC, she whined around my pole till I don't conserve. Yeah. Yeah, and in California, it's highly unlikely that Trump could have won. Yeah, exactly. It's more like a symbolic vote. I think you should always vote. Yeah, don't vote because of like strategy. That's dumb. Vote for who you believe in. Joseph be like, read my jokes, boy. Get back here. Okay. It's 4 a.m. I do what I want. I'm not Republican. I think my entire life I've been very liberal. I have become very dismayed with the Democratic Party though in the last like 5 to 6 years. So I would say independent. But no, I can't get behind like what? Some of the Republican stuff is just fucking dumb. Some of it's cool. Some of it I agree with it. Does Canada even have a government? They're about to become the 51st state. All right, let me see what Isabella's was saying. Parameterize the unit circle by that, okay. And then DR is that, okay. Oh, I see. And then, do you want us to plug that in, Isabella? I think that's kind of what Isabella's saying to do. I actually really like that, Isabella. That's cool. Yeah. All right, let's take this. We're China. You and I love Trumpy. I don't love Trump. Dude, he's not a good guy. He's a liar. Banks won't loan him money. That should tell you something. He doesn't pay people. I think it's good that he at least like brought out, some underlying festering issues that weren't getting dealt with. I'll give him that. He was good for that at least. All right, let's do it. So I'm going to say that x is equal to r cosine theta. Right, or cosine t. I like that. Y is equal to r sine t. I agree with that. And then yes, z is equal to 0 because we're in the xy plane. And then dr, good, I like that, is going to be negative sine t, comma, cosine t, 0. This is beautiful, by the way, yeah. Dude, how did my Twitch find like did my Twitch find the Rumble chat or Kick or what is it? What's the one that all the groypers are on these days? I think it's Rumble. Okay. Negative r sine t, and then this is cool. X squared plus y squared is equal to r squared. Yeah, the Rumble chat. I thought about streaming math help on Rumble, but I don't know. I don't know if those kids. Well, first of all, yeah, I don't. Well, actually, it would be a good target demographic, though, wouldn't it? Right? Those are people that are hard to reach. That we need to get more involved with math and not thinking it's just for nerds and shit. Yes. Yeah, don't get Zach started on AI though. Don't do it. Republicans don't like education? I didn't say Republicans. I just said like the people on Kick and Rumble sometimes don't, well, in any sort of community where like you're just spending a lot of time online, your grades usually tend to suffer.
You're not that guy, pal. Trust me. You're not that guy.
It's why like we do a lot with like kids who play a lot of video games, because if you're playing a lot of video games, you're probably not spending a lot of time on your schoolwork. So we try to, you know, bring those people into the fray of like, hey, do well in school. All right, let's see. my grades have suffered from watching too much Zach AI. I respect Zach for doing it the right way. Like for his coding, doing it without vibe coding, I super respect. Cause man, I don't know if I could do it. Just learning, it would take me so long just to learn all the syntax. Okay, so then this is r cosine squared t. Oh, and a dot product means we add them, right? So this times this, plus this times this, plus this times this. Yeah, right? So then this is plus, wait, then this is positive, right? Plus r cosine squared t over r squared. You learned all this and then you took your master in computer science? Okay, cool. This cancels, this cancels. Oh, this is very cool, right? Wait, and then dr, is that dt? Oh, wait. There is no r on this, right? Yeah, sorry. X is just equal to, because we're doing it on the radius of, r equals 1. Beautiful, even more beautiful. Wow, I didn't even notice that. Okay, cool. That's this. There we go. Oh, sorry. Right, okay, but r squared is equal to 1. Oh, man. This is so pretty, Isabella. Thank you for doing this for me. Beautiful. Okay. Yes, so you get sine squared plus cosine squared. That's the integral, right? And then it's that dt, which is then just equal to the integral of 1 dt. So it's just equal to t, right? But then, and then t goes from 0 to 2 pi. It is. Okay, so then the answer is just 2 pi, which is not 0. Oh, beautiful.
That's dope.
Cool. Very good job there. Nice. Who is this? Is DeSantis? Very cool. Ding, ding, ding. And it's not 0. Nothing wrong with boomers. Millennials, the ones ruining our country and giving out needles to... Dude, what? What? Bish Llama, dude. What are you just regurgitating, dog, dude? Needles to addicts in Oregon was like 4 years ago, too. Like, what? That's old. Super old. All right. Good job, DeSantis. I like that. It was a fun question. Thank you, Isabella, for the help on that one. I really needed the parameterization. You get your news from X headlines. Yeah, probably. I get my news from /poll, which I don't think I can do anymore because now I know it's like a Jeffrey Epstein Mossad operation. But used to be the unbiased source of the internet, right? Okay, let's see. What's the next question? Tyler Oliveira? I don't even know who that is. What do we think about Candace Owens? Bishlama. Ooh, Gabriel's horn. This is a fun case of you can fill it, but you can't code it, right? Candy's nuts hit my mouth. Damn it, Bishlama. Yeah. This is a fun one actually, and I think it comes down to the surface area diverges, but the volume does not. I forget why. There's a really cool reason why it doesn't. You can fill it, but you can't code it. No, it's literally the thing, dude. No, that's not me. I did not come up with that. Dude, it's
literally a thing. Yes, get the baby voice going. There you go. You get the baby voice, Crispin. Yeah, here it is, dude. This is what I'm fucking talking about, dude. I'm not crazy. You can fill it, but you can't code it. Yeah. What a voice. What a voice indeed. Yeah. That's pretty cool.
How do you need to hydrate? Thank you, JC. Bishlama, I hope I can fill your brain with knowledge. If you want to like follow along and like learn some stuff here, might help you out. You know, we're trying to get above room temperature IQs. You know, in society. Which measures the surface area of the solid revolution trace is that. Sorry, what are you saying, Manix? Do you think you could go over when to use the disk washer versus the shell method when you're done? Like, more so, what to look for. Okay. So, you can use, Manix, you can use the disk and washer method all the time. The only difference is that sometimes the integral is, like, really nasty to deal with. Okay? I think, in general... Yeah, let's go over like what the difference is. So let's say, for instance, you have something like this, and you're trying to revolve it around, right? That one is a Torricelli's trumpet. Yeah, Gabriel's horn, I think, right? Yeah. So in this case, right, volume is equal to pi, and then it's like r squared. And in this case, it would be dx, right? Yeah, dope, dude, yes. Appreciate you, Chris, man, whatever. So, in this case, this integral isn't bad to do if you have, like, y is equal to something, right? Because you just have to do the r refers to the distance from your axis of rotation to where the outer radius of your function is, okay? So, as long as this thing looks nice, this is probably what you want to do. Now, where this can, like, kind of start to mess up, right? Let's say, for instance, let's say this is equal to, y is equal to 1 over, like, x to the 5th, I guess, right? Let's say that function is equal to that. Some chappy. I love that Pen's just sparring in the chat. Please keep doing it, Pen. Okay. Let's say you're revolving around this direction. Okay. In this case, right, if you were to do the disk method, Manix, now you'd have to integrate. So this would be pi, and then this would be r squared, but now you're integrating with respect to dy, right? Because this is at how you're like building the disks. And r, in this case, has to now refer to this distance right here, which is equal to the x coordinate of this. So you'd have to rearrange this to get x is equal to 1 over y all to like the 1/5. and then that would go in, and then you'd have to integrate with this with respect to y. This isn't so bad, but if this has like anything else on it, like x squared plus like 3 or something, then this gets horrendous. Trying to rearrange this for x equals, and then doing that integral with respect to dy. This is where the washer method starts to mess up. It's not impossible to set it up, but the integral becomes incredibly difficult to deal with. So instead of doing that, yeah, let's say for instance this was x to the 5th, and then like, I don't know, like, yeah, plus 5 or something, right? Yeah. But let's do what the shell method would be. So the shell method says, I'm now going to create a bunch of these shells, and that's going to be 2 pi, and then it's RH, and then this becomes dx. The nice thing about integral being dx is my function is already in terms of x, and it's very easy. I don't have to rearrange things here, right? So in this case, r ends up just being the x coordinate of the function. It just ends up being x. And then the height is simply this. It's just the y value of the function, which would be 1 over x to the 5th plus 5. Okay? This is a much easier integral to do. Do you see that, Mannix? Yeah. So it kind of refers to this. In general, I think the only time you're really going to have... You're really going to want to prefer the shell method is when you're rotating about a vertical line, because then your function has to, like, flip. You have to invert it to solve for x in order to do the disk and washer method. Whereas when you do the shell method, if it's a vertical line, your differential is still dx, which means you don't have to really fuck with this very much, which makes the integral really, really nice. Yeah. So that's where it comes from. Yeah, you're welcome, Mannix. You cannot control energy. I don't even know what's going on in chat. You guys keep going. Okay. By comparing the two integrals, we see that for every finite value b is greater than 1, this is greater than this. Sure. Okay. However, the integral of this converges, or for the volume converges. Calculate it. Okay, cool. So, oh, they just want you to calculate this, or you just do this integral. It's easy, right? Oh, thank you, Eric. I appreciate that. Yeah, I do cast a very wide net. We're not very specialized. We do everything math or science, from like chemistry to stats to biology, physics, you name it, probability, and it's everywhere from like middle school up through like college. So yeah, some of this stuff is tricky, and like you wouldn't understand if you're in middle school or high school. But then some of the stuff we do, like this, right? This is very approachable from, I would say, a high school, maybe even a middle school level question, you know? So, but that's the beauty of it, because even when, right, we were doing this question, I forget who it was, but someone said, oh man, like, I didn't know about that one trick, and like, I'm in college. You can still learn from simple questions. There are tricks that maybe got glossed over, or you just don't remember. Knowledge happens at all different levels. Yes. I got beans, greens, potatoes, tomatoes, lamb, ram. Okay. Yeah. I think this question is easy. You just calculate this integral, which, whatever. What is that? That's pi x to the minus 2, 1 to infinity dx. So you just raise the power, divide by a new power. So it's negative pi over x from 1 to infinity. So what? That's 0 minus pi over 1. Oh, so it's just equal to pi. Beautiful. Cool. Faizan says, yo, actual, do you think online tests or in-person tests are better for exams? From whose perspective? From a student's perspective, online ones are easier. Oh, yeah. Because you can cheat. But I think from a professor perspective, I always prefer in-person because you can actually measure what students know. Yes. Thank you, Pen.
Good
Back to video editing. I hope to see your videos. I appreciate you bantering with the chat. We've had a very interesting chat today, which I think is cool. Again, I pride myself on having an open mind. And I think even if people come into atmospheres that they're not usually a part of and, you know, start ruffling some feathers with their chat and whatever, I still welcome it, because otherwise I think we as a society just develop these bubbles where we're very closed off and we never talk to other people outside our bubble, and I think that's wrong. So yeah, the banter's great. As long as you keep it like, you know, don't be no vitriol. Don't be super negative and a hater. You can say whatever the fuck you want. Just be kind. That's my only rule, I think. It's like just be kind. Okay, cool. All right. Well, we did this question, so yeah, good job. A kinder, gentler stream. Well, you know, again, and amongst all the streamers here, we have such a beautiful spectrum and variety of people in different backgrounds and stuff. Like, certain people's streams are definitely more family friendly than others. I like to call my stream kid friendly, because it's definitely not family friendly. Because I understand some parents would get upset at either things I say or things people in my chat say. But that's the real world to me. And so, as long as it's safe for the kids, I don't really care. I do have the lowest standards, yeah, because I want to be the most open. Also because the whole point of my nonprofit is to go find the kids who usually fucking hate math and have very strong opinions in communities that they are usually outcasts. And so I understand. I understand where I know where they come from. And we've reformed people. I've had people that have been on the verge of getting banned in my Discords and my whatevers just because they go pretty extreme with the temper tantrums. But some of them are now like mods in my server and have like done complete 180s with their lives, and I think that's beautiful. And it's because you just have to be patient and like not give up on these people, and eventually they see the light of like, maybe I should stop regurgitating like just slop and start thinking for myself. Yes, Pen is not family friendly. Yeah, exactly. I do have a Discord. Yes. Great question that you asked there. Here, let me put this is Vect. Sorry. The Discord, if you want to join, please, I would love to have you as a part of it. You seem like a cool person as well. The same website, actualofficehours.com. If you click here on join our Discord. Again, fun community. We're pretty open-minded. You could pretty much do or say whatever. Just, you know, keep it within the TOS so that I don't get like banned. Like, just be nice to me, please. Yes, Goldfather, bless up. All right, I still got 12 minutes left. Let's see what we can do. What was your favorite physics you took as an undergraduate? And was it because of the professor or the coursework? As an undergrad? Probably E&M. And I don't think I had the best professor for it, honestly, but I just love E&M. E&M's great. My best experience in undergraduate was the research, and that's very much the professor or the mentor. So I think it's very important to have good to pick like research mentors that can really inspire you, because that's what happens when you go to grad school. Grad school doesn't really care about did you get A's on your homework. They care about, can you conduct novel research and advance the body of knowledge in science. And that can only come from having done research, preferably with somebody that's inspiring at the undergraduate level. So much Q today. Yeah, there's a lot. There's a lot, which is great. It's because I love this. Because anything we don't get to today, I'll certainly get to another day. Or maybe Eric, if you want to, you know, have open sessions for things. I know also Zach has them as well, but also don't feel obligated because I think a bunch of people dumped a ton like at the end. Where's the link to the Discord? It was right here. Wait, where is it? So actualofficehours.com. Just click on join our Discord. Can I extend it another 2 to 3 hours?
Surprise, motherfucker.
Unfortunately, I can't. I have other kids I have to go teach tonight. Oh, this is cool. Look, it's about the Earth. Let me know, Isabella, if you can't find it. It's on that website. It just says like join our Discord. The actualofficehours.com website. You did this once? Okay, cool. A cylindrical apple core of radius A cuts through a spherical apple of radius B. How much of the apple does it remove? Okay, I kind of like this. This is a fun question. Okay, so let me think. How much of the... I assume they want it as a... Well, okay. So volume of the... Here we go. Volume of the sphere. Nice. Nice, fella.
Yeah.
Yeah, I know Jeff would love this because it's all like the globe and longitudes and latitudes. He loves all these things. Okay, the volume of a sphere, for those of you that forgot, is 4/3 pi r cubed, which in this case is gonna be 4/3 pi b cubed. Okay, and then when the cylinder comes in, it's gonna kill like a cross section of that, right? I'm trying to think how this would work then, because the volume of the cylinder isn't just what fits inside the apple, right? It's also the top and the bottom little top part. Oh man, how does this work? Okay, the volume of the sphere. Sorry, the volume of the cylinder will be at least pi r squared times h, and so that's pi a squared times h. So now we have to kind of figure out what h would be. So if this is the circle, and then this is the apple core, right? The cylinder core. Exactly. Yeah. Yep. But then I think the part that's maybe a little tricky here, Ryan, is that I have to consider this part, because the core does take away this as well, right? This all gets removed. But maybe let's figure out just the other part first. I think we can figure out the area of the red real quick, right? Like, what's the relationship? Maybe we can use, like, some triangles? Oh, nice. Yeah. Soldering a radiation... Yeah. The radiation detector beeps, yep. Yeah, physics is fun. E&M was great, Dojo. I liked E&M. E&M's, like, cool. I was really big into, like, robotics and stuff, too, so that's really why I liked it. Okay, so radius of the cylinder is A. Okay, so this is A. This right here is A, yeah? Yeah, I have access to CAD and I can answer it in 30 seconds. Yeah, you could just build this. Wait, but would CAD allow you to do it symbolically in terms of A and B? That's I think the issue here. Okay, we know that this distance is A, but also we know that this distance here is equal to B, right? Maybe I can use a triangle. Oh, you can in CAD? That's super cool. Right? This is B because this is the radius of the sphere. And then this is A. So, how can I figure out what this is? Well, isn't it a right triangle? So could I say h over 2 squared plus a squared is equal to b squared? Is that legal? Always gotta wonder, like, with the math gods, if I'm, you know, doing something horrendously not right. Right, because I'm gonna say that this is the height. Okay, so h is equal to 2 square root of b squared minus a squared? Yeah? So I think I can put that in there. And then the question becomes figuring out legal in 13 states and the District of Columbia. And then it's figuring out this part. Oh man. I need this little gap at the top. Ryan says, oh, he got it. He says it's 1/6 pi times the height, and then 3a squared plus h squared. Can you do it in just terms of a and b, though? How am I going to find that area at the top? That volume at the top? I wonder if I want to do like a spherical integral here. But then, like, R depends. You see how, like, yeah, R is going to depend on this, too? Man. Oh, man. How do you get that little top nub? Okay, let's do it this way. I know it's going to be 0 to 2 pi. And then, I got to remember, like, which coordinate system we use. Is it the physics one or the math spherical one? Which one is it? So it's 0 to 2 pi in terms of d theta. I know that. Pi h squared over 2 times 3r minus h. A is the radius of the base. Yeah, I need the volume of the spherical cap though, right? R is the radius of the base. Okay. Let me see. D theta. But then if you're taking this, and then we're definitely going up to R, right? I know I'm going up to R, which is equal to B. But then it's like A to B. Geographers might be the only person to measure phi latitude from the air. Wikipedia cheating is my friend. I'm running out of time here. I really gotta run. Man, this is a cool question though. I mean, we got this part as much, which I'm happy with. It's the cap part that's tricky. I know it's doable, but if you do the spherical integral, the R then depends on like the angle as well, right? Let's see if chat could do it real quick. When am I on again? Yeah, okay, cool. Before I end the stream, yeah, so the same website, Isabella, that people go to submit their questions here. If you click here on the streaming schedule, this has a calendar of all the different times and stuff we have. Thank you, Faizan. So we're not streaming tomorrow, but Zach will have differential equations. Math Pond will be doing some fun exercises. And then, I know this calendar says we have another 30 minutes, but my personal calendar, I have to go because I have to go teach someone else. But then on Thursday, Mavort. Who's Mavort? I don't know who this is, but cool. I love when new people get added to the calendar. So they're doing Diffie Q, I guess. Penn is doing a podcast, and then we will be on at 5 o'clock there. Yeah. Let me see. Dude, this is actually kind of cool. Let's see what it did here. So it got this, right? Oh, man. It's kind of a mess. Okay. The napkin ring volume. We'll get to it sometime. All right, let's close out the stream. All right. All right, thank you everyone for coming to Actual Education Office Hours today. Appreciate all the questions. Appreciate all the discussion. We had a lot of fun. Very lively stream today. Thank you, guys. Again, there were a lot of good questions that got asked today that I didn't get time to. Don't worry. If you ask your question, it'll still get put in our Discord. And there it'll be solved by either one of my awesome friends or we'll do it on a later stream. Napkin ring is cool. Let me just see like what we had. So that one was cool. This was a spreadsheet someone just needed to graph. Ooh, this is chemistry. Also cool. Severe electron velocity. Ooh, I don't know. This would have been interesting. I don't know how to do that, but we can figure it out. Jacob, I like this. This is great. Classic physics. You know what I love? I love that they're talking about Helm's Deep here at the bottom, dude. What? Legolas shoots an arrow. This is cool. Okay. And then let me see what else we had. Hecker had some good ones with that, and then pi. An integral day will keep the derivatives away. Oh, I don't know how to do this one. Okay, cool. All right. Anyways, yeah, so please make sure go check out the website, actualofficehours.com. That has the schedule when we stream, as well as the calendar of all the other awesome friends we stream with. I shouted out Zach. Let me shout out Eric as well. Eric's another great streamer. Can I shout out Penn? Will it let me do that? I gotta wait 51 seconds. Okay, whatever. I'll do it towards the end there. Okay, let's go raid someone. Our next stream, so we don't have a stream tomorrow, but we do on Thursday, and that'll be an hour earlier than this one started at, so that'll be 5 p.m. Pacific, 6 p.m. Mountain, 7 p.m. Central, 8 p.m. Eastern. Come on by. We'll help you guys out. Or we'll just talk about cool math shit and watch me struggle with hard questions. It's all great. It's all gravy. Let's see. Who are we following that we can go say hi to? Lots of people. Wow, lots of people on today. I haven't seen Syzygy in a while. Arduino. Who have I rated recently? Who have I not rated? Let's go say hi to Syzygy. I haven't said hi to Syzygy in a second. Looks like Syzygy is probably just talking about math and science, but that's cool. We like her. Okay. Awesome. All right. Enjoy the rest of your Tuesday. We'll see you on Thursday. Peace.
Prerequisite to join is to like boba, yes. Oh, thank you, Snaggle Fluster, for the question. Oh my god! Wow! Hello, actual education. Thank you so much for the raid.